So my name is Hongfang Liu. I'm currently at the Mayo Clinic. I'm going to talk on behalf of the Open Health Natural Language Processing Consortium to discuss the work we've done for N3C, the National COVID Cohort Collaborative. So for EHR-based observational study, many of you know that there are challenges associated with it, mainly due to major critical data points like social behavior, information, genetic information, family history information. All those are in the clinical text. And those information are critical for phenotyping and for all the other effort, but those information you cannot easily assert from the structured data. And so we did some review of those, what the natural language processing or clinical concept extraction from clinical unstructured text, how this being used, and what are the approach people using. So this is a review article, methodology review article in JBI last year, which give you some glimpse of the different approach used for extracting clinical concepts from the text, and what are the disease study areas and workflow, and what kind of disease they are talking about, or what type of document types those studies about. Want to show you the left side. Majority of the systems for extracting clinical concepts, they are using rule-based approach. Some are using hybrid, and some use machine learning, and we have some using deep learning, which about 8%. So go back to the source of OHNLP. This was established in 2009, Open Health Natural Language Processing Consortium, through the collaboration between Mayo and IBM, which released two open source NLP systems. One is the CTEX, which later become Apache CTEX. The second is the MedCat-P, which is later become the driving engine behind the IBM oncology-related effort. But we noticed there are not all the systems which releases through the clinical NLP side are, adopt UEMA or adopt those frameworks. So we end up have many kind of system. We want the OHNLP to be open source community for the clinical NLP work. So want to emphasize actually, we're not new to OHDSI community. For the OHNLP community through the collaboration of Open Natural Language Processing Collaboratory and Huaxu from UT Health. They are leading the OHDSI NLP team. I'm mainly active in the NCATS community for the work. So we have been working on trying to make NLP to be commodity for clinical translational research and for observational studies. So we have been trying to innovate in 4 different areas. As you can see here, trying to enhance multi-site NLP algorithm development, how to handling generate synthetic text data for training purpose, and advancing computational phenotyping using privacy preserving mechanisms, and lastly try to partner with different community for leveraging the NLP technology for EHR-based study. I want to go back to something which I have been trying to illustrate across different studies, which are right fair principle. So fair, you all know, which is related to the data sets, artifacts, and also the process associated with it. But coming to the tooling part, there are many things which we needed to talk about. One is the tooling is so important, because most of the EHR data, when you come up with clean data sets, you are having a process, a workflow, which we want that to be reproducible. We want that to be implementable. We also want that to be transparent and explainable. All those actually get back to, we actually, for real-world NLP AI implementation, we needed to take some approach which is evidence-based, value-added, and people-centric approach. And this is the go back to the design principle we have for the OHNLP, which is related to we needed to make sure we jump out of the research community of the clinical NLP and try to view this as a real-world NLP, real-world AI implementation. We want to empower researchers so that they can leverage EHR unstructured data for their research. So we in the last 5 years, we have been championing this idea. How do we enable NLP as a service? We implemented this at the Mayo Clinic, and basically we emphasize the domain expertise is so crucial. You must connect, preserve, and the tool sets need to engage and empower domain experts rather than we're going to take over your curation effort. And the platform needed to be responsive and scalable. So given that, this is our OHDSI development implementation framework. Want to bring that the pieces is that we take a federated NLP implementation approach, and we take a more crowdsourcing open development environment for development NLP algorithms. And the detail can be seen in the following. So we were thinking, on the ETL process side, if you view natural language processing as a ETL part of the ETL process, you need that to be deployable across different institutions. The same time, their results need to be reproducible. So you are going for a common NLP engine to facilitate in the ETL process. You don't want the same sentence from different institutions to have different NLP results. Given that, we are calling for a multi-site crowdsourcing development environment to enable that. And so first, for each individual sites, you need to have a way engaging your domain experts to have a notation interface so that you can get the semantic clinical concepts from your local institution to be able to be extracted. And then you need to, so we are jumping a little bit about expert-based system here. The major reason is related to explainability and the transparency. We noticed in the ligation problems, one of the critical things in clinical NLP where the condition can be negated. And we noticed that even we try hard to work on machine learning statistical approach to handle that, we still couldn't beat the very intuitive rule-based system. And the second thing which is causing us to take the approach is that this is everybody actually know there's potential bias in machine learning where we cannot ensure the real world data, the embedded bias be handled correctly, and the big data-based AI product can have significant societal impacts. Then if you take the ethical consideration into here, you probably will go that you want to take the approach which is more open approach, which is more domain expert engaged approach. And we have been researching on this topic for the last 5 years and trying to see why we have this kind of situation. We noticed the portability of a statistical NLP approach highly depends on the distributional statistics. The way to overcome it is you leverage a large language model and to be trained across data across many multiple sites, but we know that's not possible due to the HIPAA, the challenge associated with the de-identification of clinical notes. Of course, the sharing of those data is also not enabled. And we also noticed significant variation in documentation, and we noticed that training a statistical NLP system in a new environment institution can be quite expensive. Meanwhile, the approach we are taking using federated development crowdsourcing approach of open development seems to be a alternative to handle this. And so we also developed this modularized architecture to deployment. Through the N3C effort, we actually have the OHDSI backbone, which dramatically reduce the time each individual institution if they want to deploy this development framework, they actually can do, and they actually can ready to be implemented. So the modulization mainly due to the regulatory security privacy concern of each individual clinical data warehouse, level of IT support, and also the clinical documentation and lack of standardization, which require local optimization process need to be there. And so for more information, you can visit this link. And we have the GitHub page, which is GitHub OHRP. There are many open source related projects, clinical NLP projects released there. And lastly, this is a more kind of team effort. Besides the OHDSI community, we also, through the N3C effort, we have a vibrant, very energetic N3C NLP community, and we hope we can push this, enable more participation in this, and harvest the NLP text information for observational study. Thank you.